We're going to be looking at some function notation, just a way to kind of write out a function. And I wrote a couple examples up here of some different functions, or basically equations that you're familiar with, but instead of a y, we wrote something like an f of x, or a g of x, an h of x, or whatever we want to call that function. So the four examples I have up here are, well, maybe a better way to say that is, I want to start to learn how to evaluate some of these functions. And so the terminology that you see on this first one, where I have an f, parentheses 4, that's basically saying that's a function, and I want to find out what f of 4 is, f of 4. So what I'm going to do is I'm going to write down the f function. And it doesn't have to be the f function, it can be a g function or a w function. We just use f1 to designate function. But as you can see, I have some other functions, a g and an h. And that's solely because I have lots of functions on the board. I want us to know which function we're talking about. Are we talking about the g function or the h function? As long as we're on the same page. So to look at that first function, I want to evaluate what happens to this function when x becomes a 4, or when x is a 4. So what I'll do is I'll rewrite this equation. Instead of using the x, the variable x, I want to find out what happens when x is a 4. So I'm going to replace x with a 4. So f of 4 equals to 4 plus a 3. And then I'm going to go ahead and evaluate that out. F of 4 equals 2 times 4 plus 3. That equals 8 plus a 3 equals 11. So I can say then that the function f, the f function, evaluated 4, or f of 4, equals 11. And this 4 represents my input, or my domain. And the 11 represents my output, or my range. Let's look at another example. The next function that we have is g of x. I want to find out what happens to g of x when I evaluate it at -2. So let's write g of x. I'm going to start with my function, clean piece of paper. I want to evaluate it at -2. So g of -2, I replace the x with a -2, and likewise in the equation, everywhere I see an x, I'm going to replace it with a -2. 2 times a -2, just like 2 times an x, but 2 times -2 minus a 1. And I'm going to slowly and accurately work that out. 2 times a -2 is a -4 minus a 1. And a -4 take away 1 is a -5. So g of -2 equals a -5. And again, this -2 represents my domain, and this -5 represents my range. Next function. I have just another function. We just called it h just to help us kind of keep on page with which one we're looking at. So I'm going to rewrite h of x. In this particular case, the function is represented by r cubed minus 2r squared plus 5. Make sure I got everything written down correctly. And I want to evaluate this function, or see what happens when x equals -5. So everywhere I see an x, h of -5, I'm going to replace, well, sorry, I went from x's to r's. That should be an r in there since the function is an r. And again, it doesn't matter if it's an x as long as this function is consistent all the way through. So we're just looking at h of r. So h of -5. So everywhere I see a negative or an r, I'm going to put in a -5. You probably saw me do one other thing too that I would advise you to do. And that is, when I'm substituting a value for a particular variable, I'm going to put parentheses around it. Because as I saw this out, it's the entire -5 that's being exponented to the 3. So -5 times -5 times -5 is a -125. Minus 2 times -5 squared, which is a 25, plus a 5. And now it's just kind of grinding it on out. minus 125. Negative 2 times a 25 is a negative 50, plus a 5. I have to do one step at a time. 125 minus 50, that's a negative 175, plus a 5. And that equals 175, that equals a negative 170. So my function, h of negative 5, equals negative 170, where negative 5 is my domain value and negative 170 is my range value. The last example that we have for you is a function, capital F, of x equals 5x plus 7. But this time they want to be able to, or we want to be able to evaluate this function at a plus h. Yeah, I know. There's no numbers in there, they're just letters, they're trying to mess with us. Well, yeah they are, but it's because we can handle it. So let's evaluate this function at something funny, a plus h. Well, don't stress over it. All we do is everywhere we see an x, we insert the term that we want to evaluate it at. So let's rewrite it, f of a plus h equals 5. And remember, everywhere I see an x, or whatever variable that we're functioning of, I want to insert what we're evaluating it at. So a plus an h plus a 7. And so 5a plus 5h plus 7. And there's no common terms. I can't go any farther. So this function evaluated at a plus h is 5a plus 5h plus 7. And actually this is something we may see down the road a little ways. But it's just kind of helping us kind of get a feel for it as we continue on from here. So good luck guys as you start to get an idea of what functions are and how to start to manipulate and work around with these functions as well.